Hey everybody, it's Cal here from Wise Guys Tutoring. Today we're starting our EmSAT preparation series and we're starting with the math sample paper from 2020. In this video we're going to cover questions 1 to 5, but don't worry, we're going to do all the other questions in the upcoming videos. In fact, we're not just going to be solving each question, we're going to be covering each topic of each question. So we're going to give you all the knowledge, tips, tricks, and everything you need to do absolutely great on this exam. Okay, so let's get started. The first question says, what is the solution set of the following equation? Of the following equation. Did you guys catch that? Good thing it's not an English test, right? Anyway, so let me rewrite the equation over here. So as you notice, the variable, this time the variable is in the exponent. No need to get nervous. I'll show you how to do it. What you need to do is get the bases to be the same. And then we can compare their exponents and equate their exponents, which is actually quite easy because as you can see, it'll just be a regular quadratic. But how do we do that? Obviously, we can change the 4. You know, there's some relation between 2 and 4, right? So 4 equals 2 to the something, to the power of something. Now, thankfully, this is a pretty easy one. You don't need logs, logarithm function to figure it out. We know that 4 is equal to 2 squared. So I can actually substitute 2 squared where the 4 was, and I'll rewrite my equation like this. That was the first step. So the second step is working on these indices. So I have an exponent of an exponent, right? Double exponent. What do I do with that? Well, I'll just remind you guys of the basic rules, right? So let's say I had 2 to the 4 times 2 to the 3. Well, in this case, you're supposed to add them, and this would have given you 2 to the 7. And if you were to divide, since division is the inverse of multiplication, you'll also get the inverse here. So it's 4 minus 3. This would have given you 2 to the 1 or just 2. But in our case, our special case, it's an exponent of an exponent. And this is the case where you actually have to multiply them. So it becomes 4 times 3 and it gives you 2 to the 12. In our case, we don't have numbers, but it's the same concept. You have to multiply the 2 and the x squared 4x. So what I'm going to do is just distribute my 2 to each one of those terms. And this is going to give me a new exponent, right? 2 to the 2x squared plus 8x. And that right side is still unchanged. He's bored. He's waiting for some action. So let's give it to him. So look what happens now. I have the same base, right? 2 and 2. This means that their exponents are also going to be the same. Right? How else can 2 to the something equal 2 to the minus 6? That means that this something must equal negative 6. So I'll rewrite this and it gives me 2x squared plus 8x equals negative 6. Now this is much more manageable, right? This is just a regular quadratic equation. So what I'll do is get everybody on the left side. So to get rid of that minus 6, I do plus 6. And this jealous side says me 2. These guys go away. I'm left with 2x squared plus 8x plus 6 equals 0. Now to simplify this, I notice they're all multiples of 2. So I'll just divide the whole side by 2. Everybody here gets divided by 2. And the 0, of course, me too, gets divided by 2. The nice thing about 0 is that whatever you do to it, division or multiplication wise, it's still 0. On this side though, I get x squared plus 4x plus 3. So it's much simpler. So why don't I solve it over here? Let's say this is the second part, now that we've simplified our life a little bit. So if you recall, what you're supposed to do is find two numbers that give you a product of 3 while giving you a sum of 4. And those two numbers are 1 and 3. Pretty simple. And now I plug them back in there. So what am I going to get? I'm going to get x plus 1 times x plus 3 equals 0. To solve this quadratic, now when two things are being multiplied by 0, all that means is one of them or both of them must be equal to 0. So what I'm going to do is solve this orange guy here first. All right, x plus 1 equals 0. If I want to solve this, I have to do a -1, so that these guys go away. I get a solution of x equals -1. But look at the green guy. The green guy is going to give me something different. So he can also be 0. I'll set this one to 0, which would also work for me. How do I solve this? I do -3, jealous guy, me too, -3, etc., etc. X equals -3. And there, my friends, you have your solutions. Okay, now we have x is -1 and x is -3. Means that the correct answer was A. It was A all along. So if any of these topics gave you any trouble, I recommend you go back and visit our earlier videos on solving one-step equations, two-step equations, solving quadratics by factorization and things like that. So let's do question number 2. It says identify the quadrant when the sum of the complex numbers 3 plus 2i and 6 minus 4i is graphed. So first let's talk about what a complex number is, right? So usually we denote it by z. We say z equals a plus bi. What this is a real part. So we call these real numbers, and basically that's just any digit that you see. In this case we have 3 and we have 6. And for the second part, it's actually an imaginary number. So we call these imaginary numbers. Now, they're not imaginary in the sense that you're dreaming right now or anything like that. It's just that I factor. What's that I? Let me explain to you. In math, you might have learned that you can never take the square root of a negative, but somebody really wanted to. He really needed it. It would make so much physics and math work, and he could explain so much if he could just find the root of -1. So they created I, the square root of -1. This also means, of course, that I squared is equal to -1. Okay, so this is useful in a lot of areas of math, but in any case, we won't get too deep into it. You just have to know that this part is the imaginary number. Now, when we're adding complex numbers, when we're taking the sum of two complex numbers, it's actually really easy. What you do is add the real components together, and then you add the imaginary components together. So for us to add 3 plus 2i, and we add it to 6 minus 4i, this is just going to give me 9 minus 2i. Okay, so that's our answer. What are they asking us? They're asking us what quadrant is it in. So now we'll go over to the right so we can plot it. I want you guys to notice something. We have the x-axis and the y-axis. But when we're plotting complex numbers, this axis, the x-axis, are the real numbers, the real part, that orange part, while the y-axis is reserved for the imaginary component. Okay, so for us, the real one, as we've said, is 9, and the imaginary part is -2. So my point is going to land here, just over here, at 9 on the x-axis, which is the real axis, and -2. So my point will be just about here, right? This is 9 and 2. Okay, so my point lies here. Now we still haven't answered the question. The question is saying, what quadrant is it in? So we got to learn about the quadrants, okay? Quadrant comes from, quarter, a quadrant. This is quadrant 1, which is the Roman numeral 1, which is a capital I. And this is quadrant 2. This one is quadrant 3. And this one is quadrant 4. If you don't know your Roman numerals, it's not a big deal. I mean, it would have helped over here, but you can probably figure that this is 1, 2, 3, 4. So obviously, since it's in this quadrant down here on the bottom right, that means it's quadrant 4. And the answer is A. All right, let's move on to number 3. Let's do question number 3. The graphs for L1 and L2 are shown below. How is the system of equations classified? So our choices are consistent independent, inconsistent, and consistent dependent. So what we'll do first is we'll try to discuss what each one of those are. Okay, so consistent independent. Consistent independent means you have two lines that are completely independent, and they will have one intersection. They will have one unique solution, which is, of course, their intersection right here. So this one will be called consistent independent. Next, let's talk about consistent dependent. All right, so what that one looks like is they are two lines which are completely dependent on each other. You can think of them as being the same line. These are called consistent dependent because they depend on each other. They're leaning on each other. They are basically the same line. And lastly, we have inconsistent. Now, inconsistent means that they actually don't intersect at all. And the only way the two lines don't intersect is if they're parallel like this. So if these two lines are parallel, that means they will never ever touch and they will have no solution, and so therefore we say they are inconsistent. So just to recap here, this one, consistent independent, means there is one solution to this system of equations. It means there's one intersection. And in case they are consistent dependent, that means there is infinite solutions because they are the same line. They're just going to keep running together for eternity, if you will. And the last one, which is inconsistent, that means there are no solutions. And if there are no solutions, that means they are parallel lines, right? So double bracket, there you go. So they are parallel lines. All right, so I hope that explains these and helps you solve them. We'll go on to question number 4. Let's do question number 4. This is about statistics, so this is from my side, it's not from the EmSAT, okay? The height of the boys in a grade 10 class are normally distributed with a mean of 168 centimeters and a standard deviation of 2.5 centimeters. In which range do 95% of the heights approximately fall? So the reason that I put this nice graph here is that this is what a normal distribution looks like, okay? You might have heard of it as a bell curve, because it's kind of shaped like a bell. So that's why I put it there. And let's talk about what they mentioned in here. They mentioned the mean and they mentioned the standard deviation. So the mean is another word for average. So let's just imagine I have this set of numbers: 1, 1, 1, 2, 2, 3, and 4. Okay. First, let's talk about the mean. The mean means it's the sum of all of the values, sum of all values, divided by the number of values that you have. So for example, here, if I were to make this sum, it would be 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 4. And how many values are there? Well, there's 1, 2, 3, 4, 5, 6, 7. So I divide these by 7. If you add these up, you're going to get 14 over 7. And that means the mean is 2. Okay? That's what the mean is. So now when it comes to the median, it's just the value in the middle position. It's the value in the middle position. Remember, position, so it doesn't care what the value is. So here I have 7 numbers. That means the middle one is this guy. So my median here would be 2. And the last measure of central tendency that you need to worry about is the mode. And the mode is the most frequent value. That means it's the value that you see the most in your list. So in this case, we have 1, 2, 3 ones. Therefore, 1 will be the mode. Okay, mode is the most popular one. So that's what mean, median, and mode are. And they're measures of central tendency. Basically, what that means is they're aiming for the middle here. And in a normal distribution, when they tell you this is a normally distributed, that means all of them are the same. And they've told us that this value here is 168. Now, it says the standard deviation is 2.5. Now, standard deviation, that's a new one. Standard deviation just means how spread out. How spread out is my data. Meaning, how far are they from the mean? How far from the mean? So how far are the other heights compared to 168, which is the average? So let's talk about this. Let's look at the graph, okay? Here it says how many standard deviations are you from the mean? Now we know that the mean, as we said, is 168, and one standard deviation is 2.5 centimeters. That means if I go plus 1 standard deviation, I'm going to have 168 plus 2.5. That means here is 170.5 centimeters. Plus 2, that means I have to add another standard deviation. I add another 2.5. Now I'm at 173 centimeters. And if I add another one again, I'm at 175.5 centimeters. And you can do that the other way, right? If I remove 1 standard deviation, that's 2.5, that gives me 165.5 centimeters. And over here, if I remove another 2.5, I'm just at 163. And another 2.5 leaves me at 160.5. You can keep going, of course, but these are the values that we are most interested in, and let me tell you why. So between 1 standard deviation below and 1 standard deviation above, 68% of all values will be found in this range. So 68% of all these boys are between 165.5 and 170.5 centimeters. Okay, when you're normally distributed, that's what it's going to be. And if you take that a little bit further out, if you go 2 standard deviations below and 2 standard deviations above, in this range, you will find 95% of the boys will have heights between 163 and 173. You see? And we can take it even further. If you want to go to 3 standard deviations below and 3 standard deviations above, then 99.7% of all the heights will be in this range. So 99.7% of all these boys will probably be between 160.5 and 175.5. This is called the empirical rule. You should know these percentages of 68, meaning it's plus or minus 1 standard deviation. So let's do a quick recap, okay? So plus or minus 1 standard deviation, that means 1 standard deviation below or above the mean. In this range, you will find 68% of all the values are there. And if you take it just a little bit further, if you take 2 standard deviations, you're going to find that 95% of the people lie in that region. And if you take it even further, 3 standard deviations, that means it's 99.7% of your values will fall in that range. This is if they're normally distributed. And when you get a question, they're going to tell you it's normally distributed. So now let's go back to the question. The question says, in which range do 95% of the heights approximately fall? Well, for us, that means it's the orange range, right? That's 2 standard deviations. So 2 standard deviations is right here. They will be between 163 and 173 centimeters, giving me a correct answer of A. So let's do question number 5, which is just simplify I to the power of 37. Now we talked about this in question number 1 or number 2 rather, that I is equal to square root of -1. We've always been taught that there is no square root, there's no solution to a square root of a negative, but sometimes you really need it to work out some equations, and they invented this I, this imaginary number I. Now what this means is that I squared is equal to -1. Right? All I'm doing is, if you square both sides and these cancel out, you get I squared is -1. So let's do this. I'm going to list out the possible values of I. So I to the 1 to the power of 1 is just I. And as we've seen, I squared is equal to I times I. And we know that this is equal to -1. We can also have I cubed. Now what's I cubed? It's I times I times I. We know that these two guys right here, I times I, they're equal to -1. So when I say I times I, that's -1 times I get -I. Okay, and the last one I want to show you guys is I to the power of 4. That's I times itself 4 times. So I'm gonna do the same breakdown here. So I'm gonna take the first 2 of them. I know I times I is -1. And I also know that these guys, I times I, are also -1. So if I get -1 times -1, I to the 4 is simply equal 1, positive 1. Okay? Now we can make any combination we want using these values. So we have I 37, right? So here's I to the power of 37. So believe it or not, I've actually taken the liberty of showing you what that looks like. And here it is. Boom! So that's 37 I's, if you can believe it. So what we're going to do now is try to simplify it, right? Now how many I to the 4's do we have? Let's try to count them together. So we have one of them here. We got another one here. We got another one here. I'm just going to keep doing this just to show you. Definitely, you do not need to be doing this in an exam. Okay, I'm going to show you the shortcut in just a minute. So here we go. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have one I all by himself. Now each one of these we know is equal to 1. So this is like saying 1 times 1 times 1 times 1 9 times. And we know what that is. It's just 1. It does nothing. Multiplying 1 by itself does nothing. And what's left at the end is I. So if you're trying to simplify I to the 37, what you're going to end up with is 1 times 1 times 1 times I. So in this case, the answer is going to be A. Just good old I by himself. In an exam, of course, I don't want you listing out 37 I's, and they might even give you 99 or 98. I don't know. You don't want to be doing all those I's. So here's a shortcut. So if let's say it was I to the 37. In a test, what you need to do is divide 37 by 4. Basically, I want you to find the highest multiple of 4 that fits into 37, and that would be 36, right? So all we care about actually is that remainder. This is what you want. This is it. So what I'm trying to tell you is that I to the 37 is the same thing as I to the power of 1, which is just I. If I were to give you another example like I to the 26, what you'd have to do is divide 26 by 4. Now, what's the biggest multiple of 4 that fits into here? You know, you do a little arithmetic, know your times table, and that would be 6. So what's my remainder? My remainder is 2. That means I to the 26 is the same thing as I to the power of 2, which we know is equal to -1. So that's how you solve these, and hopefully that helped. Join me in the next video, which is going to be questions 6 to 10. Don't forget to subscribe to the channel. Make sure you like the video. If you have any questions or comments or anything like that, please leave them below. Of course, you can always get in touch with us for private lessons as well. All right, I'll see you guys in the next video.